Alright, today we're going to talk about the hyperbola. Hyperbola is the last conic section we're going to talk about. Again, we didn't really talk about circles because we've talked about those in the past. So the hyperbola is a set of all points that are whose difference is equidistant from 2 points that are called foci. So here's an example of a hyperbola. So if you were to drop 2 stones in the water, like in the picture here, the way that waves would meet would be kind of along a hyperbola. So it's kind of useful. A lot of navigation before GPS became readily available. A lot of navigation was done using hyperbolic equations and stuff. There would be signal towers that would emit a signal, and you could measure the time delay from the signals and use that to figure out what path you should take in a ship or whatnot. So nowadays, not really all that common because we have GPS, but some of the theories kind of still play behind the scenes in GPS. So let's go ahead and get started. So, well, actually, here one more picture here, if you're kind of curious, is if we spin a straight line around, the shape it would make would be a hyperbola as well. So it's kind of nifty. And if you had to make the 3D version of this, it's called a hyperboloid. All right, so 9.2, a hyperbola. So a hyperbola consists of 2 parts or branches. The line segment that joins the vertices is called the transverse axis. The midpoint of the transverse axis is the center of the hyperbola. The center lies midway between the vertices and midway between the foci. So, again, here's our vertices, here's our foci, and this axis here is the transverse axis. Notice the equation of a hyperbola is basically just the same as an ellipse, except there's a minus sign instead of a plus sign. So, x squared over a squared minus y squared over b squared equals 1, or y squared over a squared minus x squared over b squared equals 1. And now, in an ellipse, we had, c squared was equal to the bigger minus the smaller. Here, c squared is going to have to equal a squared plus b squared. We're just going to add them together. Note that you can identify a squared in the equation because it's the number under the variable preceded by a plus sign. So if the x squared term is the positive term, then the transverse axis lies along the x-axis. So basically, if you look at this guy, the x is positive, so it opens horizontally. Here, we've got the y squared is the positive term, like right up here as well, so it opens vertically. So it's not by which, in an ellipse, it was, a and b were determined by which was the bigger number. Here, it doesn't matter which is bigger or smaller. It only matters which term is positive and which term is negative. So x squared is positive, opens horizontally. Y squared is positive, then it opens vertically. All right. And as far as the derivation of the hyperbola, it's actually fairly similar to the derivation of an ellipse. So I don't want to go through it, but basically, it just the only difference is we end up adding. In the first step, we end up adding instead of subtracting, but then the rest of it's very, very similar. So I'm going to skip that for the hyperbola. All right, so finding the vertices and the foci from a hyperbola's equation. So let's find the vertices and locate the foci for a, x squared over 25 minus y squared over 16. So first things first, notice the x term is positive, so it opens horizontally, right? The transverse axis would be a horizontal line. So let me kind of show you the way I like to think about this. So if 25 is under the x squared, so I'm going to go right and left 5. And then 16 is under the y squared, so I'm going to go up and down 4. All right, so now I'm going to actually make a little box. Oops, it helps if I actually go down 4 instead of going down 3. So let's go down 4. I'm going to make a little dotted line box. You'll see why in just a second. Just makes it a lot easier, a lot less memorization if I just start off that way. Now, I said that it opens horizontally, so the left and right parts there are going to be my vertices. And if I want to figure out what my foci are, well, let's actually go ahead and write down what our vertices are. They are 5, 0 and negative 5, 0. The foci, well, I'm going to use c squared equals a squared plus b squared. So in this case, c squared equals 41, so c equals square root of 41, which again, you'll notice is somewhere between 6 and 7 because the square root of 36 is 6 and the square root of 49 is 7. So let's just call it, 6.4, 6.5, something like that. So if I'm plotting those, it's going to be about here and about here. So notice the foci are outside of the vertices on a hyperbola, whereas they are within the vertices. Sorry, I had to sneeze there. Within the vertices on an ellipse. All right. Now, hyperbolas, notice in the pictures that we have up here, well, I guess we don't, they're not drawn in there yet, but what we end up having here is some asymptotes, where we get closer and closer and closer and closer to those asymptotes. So what I can do is, notice I'm going to go through the corner of this box, and I'm going to draw my asymptotes. All right, now I can just draw it. Basically, we're not going to have to be super accurate about this. Just draw it, so make sure you're starting from the vertex, not the focus. And draw it, and there we have our hyperbola. I didn't write down what the foci were. Well, we went to the right, square root of 41, and we went to the left, square root of 41. All right, so let's do part B. Notice this is exactly the same thing, except x and y are switched. So now the 25 is under the y, so I'm going to go up and down 5. Those are going to be my vertices. And if I make my box, I'm going to go left and right 4. My foci, again, c is equal to square root of 41. So my vertices were 0, 5, and 0, negative 5. And my foci are 0, square root of 41, and 0, negative square root of 41. All right, now my asymptotes go through the corners of my box. So let's go ahead and draw my asymptotes. My foci are, again, about 6.4, 6.5, something like that. And so I go ahead and draw my hyperbola, and there I go. Find the equation of a hyperbola from its foci and its vertices. So a lot of times on these ones, just drawing it helps it get it all straight in your mind. So foci at 5 and negative 5. So I got a focus here, I got a focus here, and vertices at 0, 3, and 0, negative 3. So the center must be at 0, because the center is halfway between the foci and the vertices. So our center must be at 0. Now if I look at this, remember, c squared equals a squared plus b squared. We know a is equal to 3, because that's how far we had to go. So 3 squared. C is equal to 5. So I get 25 minus 9 equals b squared. So b equals 4. It opens vertically, so I know the y term must be the positive. And again, we went up and down 3. We went up and down 3. My mistake. So that's y squared over 9. And we went left and right 4, so 16. So that right there is our equation. It doesn't say to graph it, but let's go ahead and graph it as long as we're doing this. So we've got b was 4, so and again, that's under the x. So we're going to go left and right 4 for our box, up and down 3. And so if I, oops, that should be a dotted line. All right, so it's going to be a fairly wide one here, I think. That one didn't really write very well. And there I go. So again, all of these things, I don't think they're worth memorizing, just like with the ellipse. Like I don't, when I drew the asymptotes, I didn't really think about what the equation was, and it's you have to memorize two different things depending whether it's horizontal or vertical. Again, I'll post a separate sheet with all the formulas if you want to follow those. But like if I was looking, if you asked me what are the asymptotes on this, I'd notice the slope is I went up 3 over 4. So it'd be y equals 3/4 x and y equals negative 3/4 x. And it's as easy as that. So I don't think it's worth bothering with all these things. The one thing I will talk about is that the other axis, the one that is perpendicular, is called the conjugate axis. All right. Graph and locate the foci of x squared over 36 minus y squared over 9 equals 1. What are the equations of the asymptotes? All right, so again, square root of 36 is 6, so I'm going to go left and right 6. And remember, the x squared is positive, so it's horizontal. That's how it opens. And I'm going to go up and down 3. So I like to go draw my little rectangle here. All right, so we've got our asymptotes there. Our foci, c squared equals 36 plus 9. So c equals the square root of 45. This is equal to 3 square root of 5. And again, that's just under 7. 6.7-ish or something like that. So we're just going to go focus there. And then we approach our asymptotes. So our foci are at 3 root 5 comma 0, negative 3 root 5 comma 0. And then the other thing asks for the equation of the asymptotes. Well, the asymptotes, notice the slope of this line is going to be up 3 over 6, right? Rise over run, up 3 over 6. So the slope is 3 over 6, which is 1/2. So y equals 1/2 x. And then the other one is just downwards, so it's y equals negative 1/2 x. All right, graph and locate the foci, y squared minus 4x squared equals 4. Just like the ellipses, we need to get this where it's equal to 1. That's a key part of the equation. When we look at the default equation, that's x squared over a squared minus y squared over b squared equals 1. It must equal 1 in order for all our tricks to work. So, first thing we're going to do here is we are going to divide. Where am I here? There we go. We are going to divide by 4. And we're dividing by 4 because that's 4. So just divide that by that number. So you get y squared over 4 minus x squared equals 1. Notice you can think of x squared as x squared over 1 if it helps you. So graph and locate the foci. So y squared, notice y is positive, so it's going to be vertical, transverse axis. So I'm going to go up and down 2, and that's going to be where my vertices are. I'm going to go left and right square root of 1, which is 1, for my box. And then my asymptotes, right, are going to look going to look like that. And my foci, c squared, is going to equal 4 plus 1 gives me 5. So c equals square root of 5. So that's just above 2. So they're real close in here. And let's go ahead and graph. Okay, so we've located the foci. Let's actually write it down. We said that they were 0 root 5, comma 0 negative root 5. And if we look for the asymptotes, let's just look at this. We went up 2 over 1, so the slope is 2. So y equals 2x, and the other one's down 2 over 1, so y equals negative 2x. And we're done. All right, some more stuff to memorize if you like, but again, I don't have any of this memorized. I have a separate sheet with all this all in one spot. So the only thing really from there is to recognize if it's x minus 3 squared and y minus 1 squared, where's our center going to be? Well, our center is going to be at 3, 1. And basically what that means is we're going to go to 3, 1. Everything is going to be based on that. So when I'm drawing my rectangle and all that good stuff, it's going to just have that at the center. So it's the x squared is the positive term, so it opens left and right. It's horizontal. The number under the x term is 4, so I'm going to go left and right 2. Those are going to be my vertices. So my vertices are right there. I'm going to go up and down 1, and that's going to be for my box for my asymptotes. And then I'm going to look at c squared. Maybe I should just write out center instead for this, just so we don't confuse it here. So c squared is equal to 4 plus 1, so c is equal to square root of 5 again. So if I'm looking at my foci, again, it's a horizontal one. So what I'm going to do is, notice I'm sitting here at 3, 1. I'm going to go left and right square root of 5 to get to my foci. So my foci are like, here. They're real close in there. It's hard to draw separately. But they're just outside, right? Square root of 5 is just bigger than 2. And so if I look at this, my foci are going to be 3 plus root 5, 1, and 3 minus root 5, 1. All right, I'm starting at 3, 1. I'm just going to add root 5 to get that way, subtract root 5 to go that way. Again, that's what's in this stuff up here, but I'm not using that at all. I'm just thinking going right and left. Right is adding, left is subtracting, and we're done. So, not done with the problem though. All right, so we got our foci, and we've got our asymptotes. All right, and if we fill it in here, just be clear, I am connecting to my vertex, not my focus. It's kind of hard to see a little bit there. Maybe that's a little bit better. And there we go. So we got the foci. What are the equations of the asymptotes? Now, there's just a little additional thing we got to keep in mind, is if they were at the origin, notice my slope is up 1 over 2. So if they were at the origin, they would be y equals 1/2 x and y equals negative 1/2 x. But they're not at the origin, right? They go through the point 3, 1. So instead, I'm going to go ahead and say y minus 1 equals 1/2 x minus 3. Right? That's the transformation we need. Right 3, up 1. And then I'm going to have y minus 1 equals negative 1/2 x minus 3. And you don't have to solve it. You can just leave them in point slope form, and that's just fine. Those are our asymptotes. All right, so let's do 4x squared minus 24x minus 9y squared minus 90y minus 153 equals 0. So again, this doesn't look like anything we're used to. We need to get it into standard form. So we're going to have to use our old friend completing the square. So let's copy it down. 4x squared minus 24x, leave a little space, minus 9y squared minus 90y, leave a little space, and then let's add 153 to both sides. So let's factor out the 4. So I get x squared minus 6x. Factor out the negative 9. Gives me y squared plus 10y. And we got equals 153. Okay, so let's actually complete the square. Half of 6 is 3, squared is 9. But that 9 gets multiplied by 4, so I actually got to add 36. And then half of 5 is 25. Or half of 10 is 5. Squared is 25, is what I meant to say. And 25 times negative 9 is negative 225. So I need to balance by subtracting 225 from this side. So I end up with 189, negative 36. So I get 4x minus 3 squared minus 9y plus 5 squared equals negative 36. And let's divide both sides by negative 36 to get it equal to 1. So 4 goes in there 9 times, so I get x minus 3 squared over negative 9. So let's put the minus n on front. And then the negative 9 and negative 36 gets me to a positive 4 in the denominator. So y plus 5 squared over 4. So they kind of switch sides there. That's equal to 1. All right, so we've got everything we need to here. So our center is going to be at 3, negative 5. So 3, 1, 2, 3, negative 5. 1, 2, 3, 4, 5. So there's our center. And we're going to go up and down 2. And that's going to be where our vertices are. Remember, bigger number doesn't matter, only what's positive and what's not. And then we're going to go left and right 3 for our box. All right, so again, it opens vertically because the y is a positive term. All right, so our c squared is equal to 9 plus 4, which is equal to 13. So c is equal to the square root of 13. So, again, somewhere between 3 and 4. It's 3.5-ish. So we're going to go up about that, go down about that. And then let's draw our asymptotes. And let's draw our hyperbola. All right, so the foci, we haven't said where they are exactly, but remember we're starting at 3, negative 5, and we're going up and down. So the foci are going to be 3, and we're going to say negative 5 plus root 13, and 3, negative 5 minus root 13, just because we're going up and down that far from the center. So we got our foci. Now we need our asymptotes. Again, the slope is going to be up 2 over 3, so it's going to be 2/3. And we're centered at, again, 3, negative 5. So it's y plus 5 equals 2/3 x minus 3. And y plus 5 equals negative 2/3 x minus 3. And those are the things it asked for. And we got our graph, and we got everything. All right. So an application of hyperbolas. This is kind of nifty, I think. An explosion is recorded by 2 microphones that are 2 miles apart. Microphone M1 received the sound 3 seconds before microphone M2. Assuming sound travels at 1,100 feet per second, determine the locations of the explosion relative to the location of the microphones. All right, so this one is actually one that a lot of people have a little bit of trouble with. So let's go ahead and set it up. So we got 2 microphones. Let's just say that this is 5,280 and negative 5,280. All right, because they're 2 miles apart, so 1 mile. If we place it where the center is on the origin, we're going 1 mile to the right, 1 mile to the left. 5,280 feet in a mile. Okay, so microphone M. Let's just say it doesn't really matter. Let's call this one M1. Let's call this one M2. Now, this is the hardest part to think about. So, if M1 heard the sound 33 seconds before M2, that means the sound had to travel 3,300 additional feet to get to M2. So, what that means is, well, first off, M1 and M2 are foci in this problem. Microphones are the foci. Now, if M2 is 3,300 feet further than M1, what that means is if we were to draw, let's just draw our hyperbola, right? Let's just not worry about scale or anything like that. Let's just draw our hyperbola. So let's just suppose the explosion happened right here. It didn't, but suppose it did. That means the distance from, here, let me get a different colored pen. So the distance from there to there, and the distance from there to there, must be, right, the second one must be 3,300 feet longer than the first. Notice, let's see here, I'm trying to find a way to get to my pen. So again, just let me do it again in different colors maybe. This distance here and this distance is here. The red must be 3,300 feet longer than the green. So what that tells me is notice the green is the same length as this portion right here, right? They're symmetrical. So if that's the same length and the red is 3,300 feet longer than the green, that tells me the stuff in between here, from there to there, that distance must be 3,300 feet. So using that tells me this vertex must be at half of 3,300, so 1,650 feet. So that point right there must be 1,650, and that point right there must be negative 1,650. All right, so it opens horizontally. So the x squared term is positive. It's centered at the origin, so there's no vertical shift. So we're going to have x squared over 1,650 squared minus y squared over, and we don't know that yet, equals 1. Now remember, c squared, which is the distance from the center of the focus, is going to be 5,280. So that squared is equal to 1,650 squared plus b squared. So b squared equals the square root of 5,280 squared minus 1,650 squared. So if you use our calculator for that guy, so square root, turn on here, square root of 5,280 squared minus 1,650 squared, I get b is about 5,015. Let's see, did I round properly? 5,016 if we round properly. All right, so 5,016 squared. Or if we wanted to, actually, we could leave it as a squared, 251,559,00. So 251,559,00. All right, so basically anywhere on that hyperbola would be an appropriate location for the explosion. And that's all there is to it.